so we can get the show on the road. Okay. Afternoon, ladies and gentlemen. Welcome to the Thursday tutorial. As mentioned in the lecture this morning, we're going to be covering something you missed in Informatics 1A, the trends, the increasing, decreasing calculation. We're not going to spend the entire lecture on this. You won't be tested directly on this year. We might include it in one practical just for the sake of it. It's not hard. It's just something a different way of doing calculations and thinking that's somewhat important. So we're going to cover this. I'll upload these slides after I make some changes. I need to add the code to it. They have no code in the slides. So I'll make some modifications to the slides and then upload it. Especially for the students watching the recording or using the slides as a study source, these won't be enough. Basic question is, how do we determine if an array is increasing or decreasing consistently? Not if it goes up occasionally and goes down occasionally, but is always going up and always going down. That's the question. How do we work that out? If you look at the picture in front of us, you see the graph is easy to see. You can see the line going up. It's easy to visualize. If we look at these sequences, sequence 1, which is it increasing or decreasing all the time? So increasing. Sequence 2, is that increasing? Sequence 3. Sequence 4. And sequence 5. The last sequence is not increasing. Okay. Immediately you can, it looks increasing, but the first value, 4 and 3. With this approach, it has to always be increasing. It can never decrease at any point in time. The way we show you how to solve it. So every value has to constantly be increasing. So as soon as there's a value that goes down, that means it's not constantly increasing anymore. So in this situation, 4, 3 is not increasing, it's decreasing. Even though after that is constantly increasing, we can't see that far. Remember, think back to your calculations of min and max. How many pieces of information can the computer compare at a single point in time? 2. Okay, so keep that in mind. A computer can only compare 2 values at a time. It doesn't see the arrays like we're seeing it on the screen now. It doesn't see all the numbers. So for us as humans, it's a lot easier to see an increasing, decreasing off the bat because we can see the whole sequence. For a computer can only see 2 terms at a time. All we need is the next value to be bigger than the previous one. Correct. That's all we're looking for. All we're looking for is that the next value is bigger. Okay, and that's all we actually do in the calculation. I'm going to show you how to calculate it in a few minutes. It's not that hard. It just takes a bit of thinking to wrap your head around it. It's similar to min-max, but with an added clause in it, I guess, or added condition. And it's a good example of when to use a while loop, actually, because we don't use a for loop, we use a while loop. So the limitation is we only can compare 2 values at a time, which you can tell at a glance. Now, ignoring that. The problem, like I mentioned, is similar to the min-max. You only can see 2 values at a time. So we've got to navigate elements of the array, except we've got to stop at the second last element. So we can't go all the way to the end. So we would stop here. The loop would stop here because we would compare 9 and 10. We can't compare 10 and then something else. So just be careful of that with the calculation. We would go from 1 all the way to 9 and never actually go to 10. We would compare 9 to 10, yes, but we're never going to compare 10 to anything else. So that's something to keep in mind with this calculation, is we stop at the second last element. Okay. Also stop when you realize the array is not increasing any longer. as like a bubble sort or sort of part of. I haven't done bubble sorting in a long time, and most students won't know what a bubble sort is, so I'm not going to discuss that. Sorry. I'm going to try to keep it to basic information. I apologize if my dog is coming through in the mic. So there's two things we have to keep in mind. We have to keep in mind of where we are inside the array, so we don't go outside the bounds of the array. Second thing we have to keep in mind of is it increasing? Is it still increasing? At any point it stops increasing, we stop comparing. Okay, we're not going to keep comparing values if we know it's no longer an increasing calculation or decreasing sequence for that matter. As soon as you find a situation where it's no longer increasing or no longer decreasing, we stop the comparison. There's no need to continue the comparison. Okay, so you just give up at that point. So the algorithm starts at the first element. You expect it to be increasing or decreasing. Now I'll get to that point. That's an excellent question in chat. So if the number is equal, what will it stop? No. If it's the same value, we actually just ignore it, or you can technically stop as well, because then it's no longer increasing. Yeah, that's actually a good point. It's no longer increasing if the number's equal. So yeah, it would also stop there, because then it hits a plateau. So we could always stop as soon as it hits a equal or less than. So what we do is we first off, we assume that it's increasing. We start with the assumption it's increasing, yes. Then we go through the array and check. And we always check through and see, okay, is the value still increasing? Yeah, wrong way. Like, I think this one here, I would say this is no longer increasing because it hits a plateau in terms of the calculation and what we're looking at. Because that does hit a plateau, it would no longer be increasing as it's ended off on 6.6 and then goes up to 8. Depends on the calculation, but we'll go with the if it equals also no longer increasing. Okay, so if it is still increasing, we move on. If it's no longer increasing, we stop and we tell it to stop. So the approach is we start with the first element, as all like a min-max. We start with the assumption that it is increasing or decreasing, depends on what you're calculating. And then we start the navigation. And we check every single time that our current element is smaller than the next element. Okay? If it is smaller, great. If it isn't smaller, we have a problem, we have to stop. Okay, and most of you either watching this or listening in or either going what or you understand. And so we're going to look at it properly now. So we're going to look at the algorithm. And this is why I need to add to the slides, because the algorithm isn't in the slides. So I need to add the code and a couple other points to it. So basically, we're using a Boolean. We start with a is increasing, we set it to true, and we start with a while loop. Any ideas why we're using a while loop, ladies and gentlemen, of all things? Whenever we work with arrays, we always work with a for loop, correct? But in this case, we're using a while loop. Anyone want to guess why? For loops will run to the end. What's the problem with that? Because we don't know when the end term is. To break the condition when it's no longer true, we don't know how many times we are going to loop. Our loops can stop at any point. I'm starting to get the right approach here. You guys are getting on the right terms now. It's not to do with stopping at the second last term. It's to do with the fact that we don't know when it's going to stop, technically, and it can stop at any point in time. Can a for loop stop at any point in time? From what you guys know. Okay, no. For loops are designed not to ever stop. There is a way to stop them. If we have time, I might show you how to break a for loop. But a while loop especially is designed to continue under a condition. So while something is true, it continues to loop, okay? And it will loop indefinitely while the condition is true. So it's very useful when you have a situation of you don't know how long it's going to loop for. In terms of, it might loop once, it might loop 5 times, it might loop 6 times. You don't know. So a while loop is more beneficial when it has a condition. A for loop is fantastic when you know you're going from 1 to 10, 1 to 20. Perfect, that's a for loop. It has a fixed point. A while loop is more suited for an unknown ending. Okay, so it's a more applicable approach to this type of calculation. So what I did earlier is I wrote out the code, and I'm going to delete it now so we can do it together. So in this approach, I'm writing a function. I'm not going to go and write a button for it. I'm going to use a function because we can use it in more places than once. We can apply it more, and this is going to be a constantly increasing calculation. So we first start off with a assumption that is increasing as Boolean, and it's equal to true. And we start off with a counter as integer, and it starts off at 1. Okay? So we start off with that. Then we say while is increasing, and well, let me actually state it in another way so you guys, it makes a bit more sense. And counter is less than array dot length minus 1. Yeah, so don't use by ref and by val anymore in the class form. To be honest, no, I don't. By default, it's going to be a bar val. Technically, we should pass it by ref as it's an array to save memory. But remember, what is the difference between bar val and bar ref? Which is -2. I see some questions on the array.length. I'll explain why, and I made a mistake. Bar ref is shared. Bar val is what? Copy, correct. Okay, let's put it in another way that some of you may give a better understanding. If you have a brand new car, you just bought it, no one's driven it, it is brand spanking new, just come from the factory, would you give the keys to your best friend? Okay, I'm seeing a lot of no's. Why not? Precious, yes. It's South Africa. 90% chance they'll write it off. It's brand new. I might be the first one that utilized it. Okay. By ref is handing someone the keys. If they break it, it's broken. There's no coming back from it. Okay, that's a by ref. By value is you can look at it but can't touch it. By value, you can see what it is, you can work with it, but you can't change it. So generally, by default, if we don't indicate by ref, all parameters are by val in Visual Studios 2019. So if we don't indicate it's a by ref, it's automatically a by val. By ref is passing the original value, by val is copying, correct. That's the textbook definition. But it's one thing to know the textbook definition, is one thing to understand it. So just keep that in mind as well. Understanding when to use by ref and by val is also very important. Why am I using by ref in this situation? Yep, so what? It's an array, but why? It's not to do with the length of the array. No, it's not to do with the size. Ladies and gentlemen, do we want to make a copy of the entire array and pass the copy? That's what we go by ref. By ref means you can have access to the array without copying the elements. It's generally easier on the memory, especially, no, it's not to do with breaking, waste of memory, yeah. If the array has 100 elements and we pass it by val, that means we create a copy of the array of 100 elements twice, just for the sake of a calculation. If we pass it by ref, we use the original array, act, and finish with it. We're not going to, but also keep in mind, we're not going to change any elements in the array. This is purely just a calculation. It's not a situation where we're changing values. Now, the one question that came up earlier is, why am I going -1? That's to do with VB. And I'm actually incorrect on this one. Okay. With Visual Basic specifically, Visual Basic has a unique quality that is only associated to it. Whenever you create an array, it creates one more element than needed. In any other language, when you create an array of size 10, it goes from 0 to 9. In VB, it goes from 0 to 10. So when you ask for the length, it doesn't tell me it's 10, it tells me it's 11. So technically, I need to go and -2, actually. So it skips, it negates the extra element and then doesn't go to the last element in the array. Hopefully that makes sense. Again, VB, specifically VB, I haven't encountered another language. -1, problem with -1, it'll go to the very last element, which we don't want. We don't want to go to the very last element. So we want to skip the very last element, so we go -2. Okay, remember, when we hit the last element, there's nothing to compare with. Because remember, we're comparing our current value to the next value. You'll see that in the condition now. But is everyone okay with the original -1, why the -1 was there at least? Remember, only applicable to Visual Basic. Any other language will start with it's from 0 and go to the size, being whatever you set it to. So just keep that in mind. The dot length will always return the size of the array. It's a very useful command. That's why I'm not passing the size of the array through the, I don't know why someone's asking messages in Discord while I'm giving a tutorial. That's why I'm not passing the size of the array as a parameter. Why does VB do that? VB was, have you guys ever Googled the acronym for VB? What VB actually stands for? Or Visual Basic stands for? What does the basic stand for? Trying to find the original definition. Give me a second, I'm just Googling it. I think it. The basic part is beginner all-purpose symbolic instruction code. Okay, that was the basic stands for. Okay, so it's a beginner all-purpose language. So when you start, did it make sense that you started at a 0 with an array? beginning of the year, for those who didn't program before, would it make sense to say we start with the zero element 0? Okay, that's something you're not used to. So instead, VB decided, okay, fine, we'll keep the original programming at 0, but we'll give a 1 to X value, or 1 to 10 value, or 1 to 20 value, whatever the size of the array is, just to make it easier to understand. Okay, it's VB. There's nothing wrong with programming in VB. I know an ex-student that is stuck in industry programming in VB. He's not happy about it, but he's stuck with it. So you might end up stuck in industry working in VB. You never know. Okay, but getting back to topic, as we always seem to get off topic in this lovely tutorial. We're setting the array length -2 because we are negating we are avoiding the last element in the array. Okay. If we were to pass a size, say we said size as integer, then it would be size -1. Okay. But honestly, I don't see the point in always passing a size parameter. Yes, we've got someone's hand up. You can ask a question. Your mic should be available. Oh, you can't share audio. Okay. Guessing the person didn't have a question. Okay, moving on. Okay, why not array size like you've done array length? This is the two options. You can either pass an array and the size, or you can just stick with the array. And honestly, my approach is I like just to stick with the array. I don't need to know the size of the array because the array actually knows its own size. Arrays know their length. It's part of an array. Okay, it's how arrays function. Is they actually know the own length of the array. So I know you guys were taught in 1A, always keep track of the size. You need to know the size, but why do something that's been done for you as well? The dot length function of the array tells me the size. I just got to remember that I must -1 to get the correct size in VB. So the conditions are, if array counter is less than array counter +1, then. But if it is still less than, if the value I'm working with is still smaller than, what do we do? Remember, we're working with the increasing. If our current value is less than the next value, is it still increasing? Yes. Good, good, good. Now, what would we do here at the true part? What instruction would we give the computer? Good. See, one person's guessed it. One person's entered the answer. We increase the counter. So every time we have a situation where, yes, the value is still smaller than the next value, we increase counter to test the next value. If it is false and the value is smaller, what do we do? There it is. Can't stop, but we can say increasing is false. And we return is increasing. Okay. That is, how do we determine if an array is constantly increasing? By simply checking every element. Oddly enough, your min-max calculation is also standard for calculating max in most situations. Look, this isn't in a foolproof situation because you might hit a constant value, but then this code is working on if it's a constant increasing situation, not a sometimes increasing. Everyone okay with that? If we're told to display if the trend would be include the if statement. Right. If we were told to display if there is a trend, would we just include in the if statement? Now, what you would do, or kind of, let's just throw a button on here and a text box. Text box, text box, text box. Where the hell is my text box? Display. And btn test. So if we run the button, say we have a private values 10 as, what did I have it? Integer. I could say dim results as Boolean. Both side of that equals increasing. What do I call it? Values. Okay. So now I have a value of true or false. Now, would it make sense to just display true, false? Is that easy to understand from a person using the program? Let's be specific. No. So we have a statement, if results, then txt display text equals is increasing, else txt display text equals is not increasing. That's how you'd actually display it. Question, is everyone okay with what I did there? If results then. Okay. I kind of expected that. If you're not comfortable with Booleans, I just made a random guess on the size. Doesn't really matter, I could say 20. Where's the true? This is the fun part of a Boolean. A Boolean is either true or false. So if I say if results, it assumes it's the first one's true. So saying if result is the same as saying if equals true. It means the same thing. This is the shorter way of writing it out. Because results is a Boolean. The results can only be true or false, which gives us the ability to say if, explain line 22. I expected that as well. Ladies and gentlemen, I'll slowly show you like different ways of writing out code. What I've done is I've created the local variable and set it equal to the function at the same time. So this line is the same as saying result equals. Line 22 is the same as doing that. I just combined it into one line. Okay. I know you were taught in 1A to always have everything on separate lines, But in some cases, you can combine statements. Once you get more comfortable, you can start to combine certain statements into a single line. There's nothing wrong with it, as long as you understand what you're doing. So I do appreciate the asking why I did it. It is the same as saying dim results as Boolean, results equals increasing values. It's the same thing as what I've done now on the screen by saying splitting it into two lines and then saying, okay, fine, I've got the local variable. Let's make the local variable equal the result of the function. I can simply declare it and make it equal to the result of the function on the same line. I'm wondering if I should show you that, because some of you guys might abuse it. Let's ask a question. Let's see how well you guys understand functions from last semester. Do I need the results local variable? Is it actually needed? Yes, yes, no, not really. The answer is no, not really. I might be shooting myself in the foot by teaching you guys this, but yeah, that also works. The function will return a result. A function will return the result. The if statement will then take the result and compare it equal to true. No, you don't need the true either. You could technically just state that. But ladies and gentlemen, occasionally I'll show you things like this. Line number 19. Line number 19 is needed because we need an array. I'll occasionally show you things like this when we are doing tutorials and that, but please don't use them if you don't fully understand it. Okay, programming is not about showing off what you can and can't do. It's trying to get a solution. So if you don't understand something in code, don't use it because it looks cool. Only use it when you properly understand it. I mentioned in the one class that it takes, once you understand the principles of programming, you can learn a new language roughly in 6 months. It'll take 3 to 5 years to master the language. Okay, so the more you program, the more you come to understand the language, the more you come to understand the principles behind the language. So once you get a better grasp on certain things, you can do things like I've done now, and it makes sense. But if you're not comfortable with it, don't do it. Because all you're doing is shooting yourself in the foot when someone asks you to explain what the hell you just did. There's no point in doing things unless you properly understand it. And that's one thing I emphasize most of my classes. I try to emphasize. Understanding is more important than being able to type a line of code. It's easy to Google and find an instruction, but understanding that line of instruction is completely different to actually writing it out and using it. Okay, so there's a big difference between seeing code and using it and understanding what the code is actually doing. Once you understand what it's doing, then you can start manipulating it as you like and changing it to fit your needs better. But Mr. Van der Westhuizen mentioned the other day about readability of code. If the code is crap to read, you got a problem. Okay? No matter how many comments you add, if the code is hard to read, you have a problem. So sometimes doing what I've like now, it's easier to read, easier to understand. It's better this way because the next person coming along will be able to understand what you've done and maintain the code. Remember, you're not design. I know this year it seems weird that we talk about future tense. This year you're writing code that no one's maintaining. It's never going to be maintained by someone else. But eventually when you go to industry and develop projects, they need to be maintained longer than a week. They need to work longer than a week. So the code must be developed and designed in a way that it can be easily maintained and improved on without confusing the crap out of the people that have got to come after you. Because you get different type of developers. You get the designers, the developers, the testers, the maintainers, the improvers, etc. Now, the maintenance team and the team assigned to improve on a code or update a code, if they can't understand your code, there's a problem. That means you've done something wrong as the developer. And no matter how many comments you put there, it won't solve the problem. So it's important to make sure, like naming your variables, naming, commenting, those things are important so it's easy to understand what the hell the point of the variable is. Because you always could write code like this. I don't want to name it like that. Is increasing. Rename C. Rename. Compare the code I showed you 2 minutes ago to that. Which is easier to read? Okay. This is an example of crappy programming and lazy programming. Funny, Mr. Van Vesthuizen. This is a pure example of lazy, bad programming, especially if you're doing it in a team environment. It's difficult to read, difficult to understand. So it's important to keep that in mind with naming variables, naming functions, etc. It's remember, those who think IT is a solo activity, you definitely picked the wrong degree or the wrong field in industry. IT is a group activity. When you work in industry, you don't work by yourself, you work in a team. How would you display if you don't know the size of the array? The array is, no, I do know the size of the array. In what context do you mean display the size? Display. Line 19. Oh, okay. I understand. Nothing really changes. You just have a second button. Um, box readum values size. And that's pretty much it. So you'd readum it, get values. You do a for loop for v equals what as integer equals 1 to size. Technically, even here you could say v equals values dot length if you wanted to, -1, and just say v equal v values v equals c and input box, get the values, and then run it through the calculation. I just went through an approach of saying static because it's easier for what I was illustrating. Okay. Look, sometimes even in the lecture slides, I'm not going to include every single line of code because some of it you should be comfortable with it. Like if it's an array, you should be okay with resizing, etc. But I'll mention if it's an important key feature, key piece in the code. I will always mention it. How would I make this to determine if it's decreasing, by the way? If this is currently working out increasing, how would I work out decreasing? One suggestion. Anyone else? Change the sign. Okay, got enough. Ladies and gentlemen, it's not that difficult. It's just that. And of course, you would show decreasing, just to make sure it makes sense. And that's pretty much all you have to do. Counter still remains the same. The counter still has to go through all the elements. It doesn't change. It just, the only difference is now you're checking that every element next is smaller. Previously, we were checking every element is larger. Now we're checking if every next element is smaller. And we continue on to that. How do we determine if the remains the same and doesn't change means the trend? But how would we determine if it remains the same and doesn't change? I mean the trend. Thing is, are we considering equal to? Are we going greater than equal to? No, okay. So if it remains the same, it would trigger the false. If it's like the one example, we had 6 value, that is not less than, it would trigger the false and then say it's not decreasing anymore. Okay. But that's what the one thing we had to cover from Informatics 1A that wasn't covered last semester. I think we might add it to a practical somewhere along the way. It's not hard to do, ladies and gentlemen, but I will update the lecture slides to include the code because I don't like lecture slides that don't have code and just pictures. It doesn't help. There must be some code. So I will include the code so you guys can actually see what it is later on, especially for those watching the videos or using those lecture slides as a pure resource. I know there's no textbook for this course as well, which makes it a bit more interesting. That's the one thing we had to cover today is the increasing, decreasing trend. You guys comfortable with it? Do we need to go over it again? Getting no responses. Is my mic working? No. You're not comfortable. Must I go over it again? Okay, I'm assuming I mustn't go over it again. Uncomfortable. Okay, good to see. Comfortable. Okay, look, ladies and also remember this is recorded and put on YouTube, so you can always watch it again. There's no limitations on how many times you can watch the YouTube videos. As mentioned, the ones on Eve, I have to remove them after a month because we don't want to use up too much space on Eve in the course of the semester. Then to what? Then let's actually switch over to Q&A for constructors and anything else we've covered up into this point because we've done composition. Okay, so this is only done in the form. It doesn't have anything to do with the class. No, it can be done for a class. There's nothing that says you can't have find out if a student their marks are constantly increasing or decreasing. That can be done. Then it'll be done in the class. Nothing ever is limited to the form or the class in terms of calculations. In terms of inputs and outputs, then yes, there's limitations on what's done. Your form is designed for mainly inputting and outputting information. Your class does the rest. It's okay with me. Perhaps we can move on to shared or composition. I think let's do shared first, as that's something that is new to you guys. And it's also something I'll have to bring up in class, and let's just make a note of it. There's one restriction I forgot to mention with shared that I didn't do in class. Let me just make a note of that quickly before I forget again. There's my pen. And the restriction has got to do with a shared function. Okay, what can we do? Give me an idea for a class, ladies and gentlemen. I'm running out of ideas. Not a student. No ideas for a class. What's idea generator? Okay, Mr. Van der Westhuizen's got an idea. Generators. Everyone's suffering from load shedding. Car, house, hospital. PC. PC is not a bad idea. Bed, computer. I'm actually gonna go with the computer. Gaming. No, we'll do that another time. Gaming, I'm always up for. I'm not doing an Apple. For those who missed my comment, a pear. Bloody hell, now you're just going through fruit. I'm not doing an Apple computer. My comment earlier about gaming. Some of you have asked that why do I have Minecraft and Unity on my taskbar? I am a very unique individual in my department. My PhD and master's was on gaming, ladies and gentlemen, especially specifically AI gaming or AI in games. So I get to play games for research. So gaming is always an option. For research, yes, for research. I played Horizon Zero Dawn for research. GTA is actually not a bad game for research either. The AI in GTA is interesting. It does kill itself. Fortnite, no, I look at games with AI mainly. Fortnite doesn't have much AI. Minecraft has a lot of AI, so I looked at that. Okay, it's getting back to, and actually a unique idea I can use here for shared. Commander Duty Warfare, yes, that had AI, but some broken ass AI as well. Okay, let's get back to lecture. What is this? Every computer has a unique number. Any idea what it is? Not the serial code before you give me that. a universally unique number. Nah. Product number, yeah. Mr. Van der Westhuizen, correct me if I'm wrong. The MAC address. Yeah, I know it's a network card, but every bloody computer has a network card. Okay. As Mr. Van der Westhuizen are debating that point. Every computer will have a network card or a way to connect to a network. Every network card has a unique ID called a MAC address. So we're going to use that as our way of demonstrating shared. Okay. Yeah, and it is a unique number. I think it's unilaterally across all machines. So every machine will have its MAC address. String, I think. Decimal, so technically it should be a string. Okay, so we've got to now make a way that every... No. The MAC address isn't shared. The MAC address isn't shared. Yeah, I know occasionally there was situations where MAC addresses were not assigned correctly, but going with the assumption that the MAC addresses were assigned correctly. Okay, that's where MAC spoofing came in. But in theory, all machines should have a unique MAC address, correct, Mr. Van der Westhuizen, since you are throwing in comments and okay, yes, thank you. Theoretically, every machine should have a unique MAC address. There have been mistakes in the past, but we're going to write code that doesn't have that mistake. And no, the MAC address shouldn't be private shared. The MAC address is unique to each object. Okay? What we're going to have private shared is a next MAC address. And this doesn't work with string, so we're going to fall back to integer. I could do a string, but we're not going to do now. I'm going to go with something that's a bit more simple. Okay. So what we're doing is we're going to have the MAC address for the object, and the shared one is going to be the next MAC address, so the next machine's MAC address. So every time we make a new object, it gets the MAC address, and we almost essentially generating, we make sure we have a next MAC address available for the next individual. Okay, so when we public sub new, the MAC address is equal to the next MAC address, and we increase the MAC address by 1. So the next time we create a computer, the next one will get its new number. Okay, so it automatically goes and tunes like this MAC address is 1, it'll push out the next value. So it automatically generates a unique value, a semi-unique value for the next computer that's being developed or created. Now, the one thing I mentioned, a restriction with shared functions. A shared function cannot access instance variables. I'm partly nervous to initialize it, but it's not initialized to a number when it starts. Now, I'm hoping this doesn't break. Yeah, okay, we'll see if this breaks it or not. It shouldn't. There's no need to initialize. Generally, to play things safe, you want to initialize. But let's see what happens. I'll show you how to use shared now. Okay. But I need you guys to understand that shared doesn't belong to an object. It belongs to the class. Shared belongs to the class. One thing I need to mention. Let me show you this now. Public shared function example return. I know this is not how you do it, but I'm just trying to illustrate a point. What next? It doesn't want to do it. Thank you. Okay. I know we'd use a property method. I know that, but I want to show you something about a shared function right now. So it doesn't really matter it doesn't matter the method I'm using. A shared function cannot work with instance variables. Okay, you see that it's underlined the MAC address in red. A shared function cannot work with any variable that is not shared. So it's complaining because it cannot access this variable. This variable doesn't exist in its function. So be very careful with the shared function. Shared functions can only use shared variables. Everyone okay with that point? If you have a shared function, let's do a property method. Since I did that, I discovered that the other day. Public shared read only. MAC address get public shared read only property method. Why isn't it generating my export get? Does it be that order? Huh, how did I do that other day? There it is. Okay. So something that's shared never can access instance variables. So I cannot return by mistake the MAC address. Since it's not shared, it belongs in a different scope to the rest of the program. Okay, so things that are shared belong to the class. They are then can be used anywhere that is shared. Okay, I can use a shared variable in an unshared method, yes, but I cannot use an instance variable in a shared function or property method or subroutine. Okay, it has to. You only can work with shared variables. Next MAC. Yes. Okay. How we use it in the form. Okay, wait. Scrap that. It's actually quite easy. Using shared is quite simple. To access shared in the form, you don't call the object. We go computer dot, and there's the read-only method. Okay, to access a shared function or say a shared variable, you go directly with the class name. So class name dot whatever you want. Not object, never object. A shared function, a shared Instance variable or shared function is only accessible via the class name. Everyone okay with that? Ladies and gentlemen, everyone's gone quiet. I know it's giving me an error because I'm not displaying it. Display dot text string. Yeah, that's why it's giving me an error, because it's not being displayed. But the important point is how to access the shared. You access it through the class name, not through the object, not through anything else, but the class name. The only place you don't need to do it by the class name is in the class itself. That so, okay. So shared within the class can be accessed directly. Shared outside the class needs to be accessed by the class name. And that's pretty much it. But every object that's created from the computer shares that piece of memory of shared. They don't all have their own little next Mac ID. They all share the same variable, which is the important point. So let me go into, I tried to draw this out the other day. So every computer that's created, say each circle is a computer being made, they all will share a common, they all share the same piece of memory, being the shared variable. They won't have their own next Mac ID. They all share the same Mac ID. So instead of having each one keeping track of its own, the next Mac ID, you have one that is, what's the right word? Not uniformly or consistently or unilaterally, technically, shared amongst all of them. So they all have access to this one variable, and whatever changes made to this variable can affect all the objects. Any modification to the number can also affect all the objects going down. Hope that made it a bit easier to understand. Okay, there's about half an hour left to the TUT. Any other things you want me to discuss, ladies and gentlemen? What kind of changes can be a variable shake affect an object? Okay, we're gonna discuss it later on, where we have event handling. Technically, it could trigger an event and cause the objects to react in a certain way, like an alarm system. If the shared variable is negative, it suddenly triggers all the objects to act in a certain way. If the shared variable is positive, the objects act in a different way. It just depends on how you apply it. Right now, I can't think of a example that would make sense to the amount of knowledge you guys have in IT, at least. Some things make more sense over time, put it that way. Honestly, some of the stuff you get taught in first year, it only sank in my third year when I actually started to use it properly. Did I realize what the hell I was doing? So some things we do in first year, you know about it, but understanding how to use it only comes in later when you have to actually apply it properly. So just keep that in mind as well. But you have the basic idea. Okay, we have a question up. So how would you set an array that accepts values in a class? My problem is calling a method in a different method. In a class. Calling a method in the same two methods. So you have two methods in the same class, one calls the other one. Okay, that I can do. Let's go with budget. No. Accounts. Maybe that'll work. So we have an account. It has a private amount, integer, no, double. It has transactions as double. Okay, so the transactions can be negative or positive, affecting the amount. So I want to know what the total transactions are to affect the amount, and what the average transactions are. So we'd have two functions, private. Let me show you utility as well, kind of. Functions, total transactions is double, and this is dim total as double equals 0 for t equal t as integer equals 1 equals 1 to transactions dot length minus 1 total plus equals transactions t return total. Okay. Now if I want the average, do I go and recalculate the average, the total? Remember, what is average? Ladies and gentlemen, what is average? Average of the transactions. Let me give a specific question, not just vague. Sum minus number of elements, correct. So if I want the average of the transactions and I've got a function that gives me the total, why do I need to go and do it again? Total transactions divided by length minus 1. So here's me calling a function or a method inside a method from another method. So average will call total transactions. It'll calculate the total and give me the total, the average. From the form side, let's do this. Count. I'll be with you now. Just got to finish this line of thought before I forget what I'm doing. As count. And I can go obj count equals new count, and I can call obj account dot. Now, if you look at the list, total isn't here. I know it's a bit small to see. But total isn't part of the options, averages. So I don't give the person the ability to work out the total. I do control it. I can just give them the ability to calculate the average per se. So that's somewhat a very rough example of a utility function. Let me just catch up with the questions. Do you need to put the transaction -1 in the brackets because of BODMAS? Transaction. Oh, good question. Good question. That I would probably agree with. You probably have to do with BODMAS. The code can mess up if you don't notice it is. Noticed it in this week's prac. Okay. I see you're answering another person. Sir, how do we access those different option tables while coding? Then when using a sub, how would you call it? And the last one, could you have one function for getting an average, passing the array using by ref? Okay, let's answer. Okay, I agree with Oliver and Lichman about the brackets. That could mess up your code. So how do you get those different options when you're coding? I've taken off the autocomplete. So I know Mr. van der Westhuizen has also taken it off because it generates all this random crap as well. How I get it is control spacebar. Press dot and control spacebar, and it automatically pops up everything associated to that object or that class. Normally it'll pop up by default if you have the autocomplete listed on, but the autocomplete also gives you options that don't actually make sense. Then, so how would you use a sub? How would you call it? Same way. Okay, a subroutine kind of accesses it the same way. You just call the subroutine. There's no real difference between a function and a subroutine, except one returns or one doesn't. So calling it is the same. Could we just have one function for getting average, passing the average by ref? You could, but you could have one function to calculate the average, but I was illustrating or trying to show how to call one method inside another method, and I'm also illustrating how to use one example of utility methods. Is it possible to return an array? Yes, it is possible to return an array. Okay. Because what I can do now is public function update account. Well, actually, this is a sub. This would be a sub. And we say amount plus equals total transactions. Now that would automatically update the account if depending on the transactions, if they're positive or negative. So I could say I've taken out money, added money, minus money, added money, minus money, and the total result would affect the amount. So you could just use that as a one function. So I would just say here, obj object dot update, and then I'm invoking a function here, a subroutine here, a function here. This should technically be being sent somewhere because it's a function. Okay. Is it possible to return an array? Yes, it is possible. And again, ladies and gentlemen, please take everything I do in these tutorials and Mr. van der Westhuizen's tutorials with understanding that we're showing you things, but don't automatically just use them for the sake of using them. Only use them once you properly understand. Else it just goes bad for everyone. Okay. We don't want to limit the amount of information you guys get exposed to. We don't want to restrict that No, you only can know this and know this and know this. It's about understanding what you're doing, okay, and applying the right tools. So don't just jump in head first and start using stuff because it looks cool. If you understand it, by all means. But you're going to face one situation with the assistants is they're going to ask you to explain it. So just be very careful there. To answer Mr. Oliver's question about returning a function, an array, public function, I have no idea, example as double and values as double return. Okay, I'm not doing any calculations, I know that. Oh, no. I'm not going to do that because that's going against what I say about input boxes in classes, boxes in classes. So you could do that in the form, yeah. In a class, unless the values already exist, you could return it, yeah. But remember, an array, a single variable, is just a piece of memory. Okay, let me explain this in another way. Blackboard, whiteboard. So if I have a variable name, all a variable name is, ladies and gentlemen, is a direction, a pointer. It points to a piece of memory in our RAM. So whether if the variable points to a array, or it points to a single variable, doesn't really matter. A variable name just is a pointer to the information in memory. So passing example, I'm passing the pointer to the memory. So it's not about if you can, it's, okay, in IT, it's not about if you can, it's can you have the right amount of processing and time to do it. It's always possible with enough time, generally. But that's the thing is, with a single variable, it holds one value. With an array, it holds more than one. So an array will point to multiple positions. So yes, you can return an array because it will point to the whole array, and then you can point to specific elements in the array. But again, it's not something you're going to use often. It's in specific situations. Okay. Any other questions? Because now I'm just fielding questions from all over the place. Everyone's gone silent. Have I gone? No, my system's still working. Can we go over composition for the last time? Sure. No issues with that. Let us do composition here. Delete. Yes, go away. Let's delete this. Okay. So with composition, you're going to have, let's work with the example of a computer. Let's stick with a computer. server computer. What does a computer have? What parts make up a computer? RAM, CPU, motherboard. Okay, so we have CPU. Okay. Let's just stick with CPU for now, else we're going to be just adding classes indefinitely. Storage, look, everything you've said, everything you guys have added, CPU, RAM, motherboard, graphics card, the core, that's the CPU, monitor, keyboard, mouse, storage, that's all part of a computer, correct? But if I do all of that, we're never going to finish in the next 10 minutes. So with composition, firstly, what makes up a CPU? Let's give it some attributes, because it doesn't make sense if it doesn't have attributes. It's going to have a brand. It's going to have number of cores. It's going to have a speed. It's going to have overclock. It's going to have all these different qualities that make up a CPU. It's also then, of course, going to have a constructor. And in there, you could set certain qualities. Then it's going to have its property methods for each one going down. Public property, brand, string, get, return. I can't spell, I see. Brand equals value. Okay, and you can continue adding down and add additional functionality, methods, etc. Okay, but we don't have the time for that. So you can add a whole bunch of stuff to this. Now, when you come to a computer, we can say that a computer has a CPU. Okay, that's the thing, is that immediately starts the composition. The fact that inside a computer, I'm saying it has a CPU. CPU. I'm just going to call it an object CPU, else we're going to have a naming conflict in a few seconds. Because I can't call the property method CPU either. So it's also going to have a public property obj CPU as CPU, get, return obj CPU, and it's going to have obj CPU equals value. Okay, so that's the property method. Now you have an option. Since there's one CPU, you can have the option of, as soon as you make the computer, build the object, you immediately say that the CPU equals a new CPU. Okay, done and dusted. You instantiate it. If you don't instantiate it, you're going to get a null reference exception. So this is one option. If you don't do it here, then you have to do it before you use the object. So say I'm in the form, I have a private computer, computer obj as computer. I'm going to say that an obj computer equals a new computer. Also, before I can go obj computer dot CPU dot sorry, it's obg CPU dot brand. Let's actually run this and see what happens. It's a lot easier to show you than actually always tell you. Okay, it's compiling. Intel. Break. Thank you. Okay, it's broken. Why is it broken? Does the CPU exist? Ladies and gentlemen, does the CPU actually exist? We made an object, but again, if we look at our object, the constructor for the computer, does it, I've got like 5 messages at once there. It doesn't create the object, okay? So if we don't do it there, then we have to do it here. And say obj computer.obj CPU equals new CPU. That's the other option you have. Now it'll work. Okay, so you either can do it in your constructor, which sometimes makes more sense to avoid errors like this, or like the example this morning I did in the tutorial, where you have an array of apples and you've got to instantiate each apple. Sometimes it makes more sense to do it in the form. So you've got to decide where the more logical position of creating the other objects is. Sometimes honestly, sometimes I prefer to do it here to simply make sure I don't stuff up later and I've forgotten to make a certain part of the computer. Okay, so sometimes it's better to do it in the constructor, but it's not always necessary. That's what I'm trying to get to. Again, we're trying to teach you the tools you need to program, not the memo. There is no memo of programming. There's only ways of solving things. Okay, for every problem, there's 1,000 ways to solve it in programming. Okay, once you know enough of it, there's lots and lots and lots of ways to solve any problem. It's just how you approach the problem determines your solution. Okay, and that's how we know genuine people are copying code, because no one's code is identical. Okay, any other questions, ladies and gentlemen? Because we've got about, so what is a module in VB? Module. If I remember correctly, let me just see if it still exists. Okay. How to explain module? A module is a subsection of code. So you would, in a module, have, I think I stand to be corrected because I haven't used modules in a very, very long time. Modules are more about having functionality. So a module will be full of functions that you can invoke functions from the module. It's not an object. It's more of a supporting role. Mr. van der Westhuizen, if you're actually listening, can you just check what the module definition is in the MS Docs are? And then we can get a proper answer for that. Okay, we'll explore other things you can add later on in the course, like interfaces, but a module are always associated to like a header file from C++ almost. A list of potential, not a header file, almost a subset of functions and subroutines that I can use throughout the project. Let's just check quickly. Module VB. Visual Basic provides several modules that enable simple and common tasks in your code, including manipulations of strings, performing mathematical calculations, okay, but that doesn't explain what a module is. Yeah, a module is basically a buildup of subroutines and functions that allow you to use them in other code without creating an object. I think that's the best way to sum it up. Okay, here's another one. A module is software components or parts of a program that contains one or more more routines. One or more independent development modules make up a program. An enterprise-level software application may contain several different modules, and each module serves unique and separate business operations. Okay, if that makes sense to you, then great. It's just a way of breaking up your program into smaller subsections. That's something we will come back to if need be. Okay, hopefully that makes sense. Look, there's a lot, like I said, I'll give away my freaking age almost. I've been programming long enough that I know the VB you guys need to know backwards, but I still don't know everything about programming. And there's lots of areas I don't know about programming. Okay, it's not something that you just know everything about. You slowly learn as you need it. So just keep that in mind. No one knows everything about programming. That's nearly impossible. As programming also evolves every couple of years. So it's important to keep up to date with programming, and you're learning a drop in the ocean in comparison to most things. You're learning a drop in the ocean of IT. So there's lots of things you'll get to know later on. Okay, there is 3 minutes left. Nah, you guys will eventually see me one day. It'll be a surprise. I'm not that old, damn it. I actually am younger than Prof. Long. No, I'm not that young either. Like, Mr. van Westhuizen's the bearded one. You probably walked past me in the department, you just don't know it. When you were still there, our footsack 88. Okay, let's stop playing a guessing game. Any valid questions left from the group? Because I'm going to stop the recording because now it's just wasting the data.